The next lesson video in Unit 8 is graphing linear inequalities, which means we're going to now include x's and y's in an well, it's not an equation, it's an inequality. So we're going to have two variables where yesterday we were dealing with just a single variable. So here we can actually graph these. And when we graph inequalities, we're still going to shade. So we need to let everybody know what the solutions can be, similar to what we were doing yesterday when we shaded on a number line. But here we're going to be shading graphs. And when we shade inequalities, we need to pay attention to a couple of things that are different than when we graph lines. So the first thing is that when we graph a linear inequality, we're literally graphing a line, but we are now including more answers because an inequality says kind of like we're restricted to certain things, but we have a lot more flexibility with what our answers can be. So we have solid lines, dashed lines, shading above and below that help us keep track of what points could actually be an answer to the inequality that we are given. So here's some key differences. Notice how the line of 3x plus 2 is staying exactly the same in each one of these four examples. The only thing that's changing, and you might want to circle this, is an inequality symbol. So the first thing that you should notice is that this is a less than symbol. We're going to shade below. There's another less than symbol. We're shading below. Here's a greater than symbol. We're shading above. Here's another greater than symbol. Shading above. If I have a less than or equal to, that's when my solid or my line is solid. So if I have a less than or equal to or greater than or equal to, my lines will be solid. But if it's less than or greater than, not equal to, we dash the line. So you might wonder, like, why are we doing that? Well, first of all of the points in this area that's shaded in every one of these examples, those are solutions. Any point on a solid line is actually also a solution because it can equal. We dash it to say, this line doesn't really exist when it comes to solutions. Like it's there, but the points on that line are not solutions. So we could graph inequalities by hand. We can use our technology. I'm going to show you how to graph this using technology. So the first thing you'll do is you'll open up a graph and you'll change it to relation mode. Then we will do y is, and in order to get your symbols, you're going to hit Control equals. So that's a greater than symbol. And then you're going to type in 2x minus 3. And as you can see, your line is now graphed for you. You can do the same stuff that we've done where we've traced it. First, change your trace step to 1. And then menu graph trace. And then you can generate all of the points on the inequality. Some of you might say, wait a second, can I just graph my y-intercept at -3 and my slope is 2/1, so up 2/1? You absolutely can. So we're just graphing it like a normal line. But here is where we need to be a little careful. If we only have a greater than symbol, this means that my line is going to be dashed. So I'm going to dash this line. Still going to add arrows. Still going to label it. And then you can tell from the calculator that we also need to shade. I like to shade with perpendicular lines like this. Please don't color in each individual box. Save that for art class, not for math. And then a lot of times what we're going to do is determine if a point is a solution. So the first thing that we're going to do is plot the point -3, +4. Since that point is falling in the shaded area, this is a solution. So we're going to say that, yes, because it is in the shaded area. A couple other things that I want to point out is if I had asked you if this point here, 3, 3, were a point, we would say no, because it's on a dashed line. So anytime a point is in this shaded area on a solid line, it is a solution. That means if I took this point here and substituted in my x and y in there and simplified, it would create a true statement. So 4 is greater than 2 times negative 3 minus 3. Is 4 bigger than negative 6 minus 3? Sure is. Negative 6 minus 3 is negative 9. That's true. So points on dashed lines and not in shaded areas would not be solutions to an inequality. Sometimes your inequality will not be written in standard form where it's like y is equal to mx plus b, where the equal sign is an inequality. You can graph that using your calculator in relation mode as well. And also, you could write it in y mx plus b form, but really, I think using your technology is very helpful.